The fundamental problem facing humanity today is not aircraft, but infrastructure of a new civilization. Our platform integrates unmanned airports and Earth space vehicles into a single unified system. 2 patents have already been filed, and the structure is defined through 17 drawings and detailed specifications. Once realized, Earth becomes a one-day living zone, and space becomes everyday infrastructure. What you are seeing is not a concept, but a structure protected by patents. Humanity has long dreamed of technologies that move faster, safer, and farther. Yet in reality, our transportation systems have remained trapped behind for persistent barriers: speed, cost, safety, and the environment, repeating the same patterns for decades. The system introduced today is a new approach that redesigns those barriers at their core. It is an entirely new mobility and space platform that connects Earth and space into a single continuous flow. This system operates as an organic structure in which unmanned aviation, the support platform, Earth-use vehicles, and space-use vehicles function together, simultaneously innovating terrestrial mobility and space access. 1. Unmanned airports, the gateway to future mobility. Future airports will no longer be centered on runways. Instead, they are designed around a new structure in which the support platform ascends and descends in near vertical motion, carrying and recovering vehicles. Inside the unmanned airport are integrated power supply stations, ESS energy storage systems, automated maintenance hangars, control centers, and modular cargo and passenger handling systems. The goal is fully automated operation with minimal ground personnel. Each airport operates for support platforms in rotation, enabling a single airport to conduct hundreds of operations per day. 2. The support platform, the link between Earth and space. The support platform is the core and central element of the system. Earth-use vehicles separate and launch between altitudes of 13 kilometers and 25 kilometers, while space-use vehicles are safely transported from 50 kilometers up to the 100 kilometers Kármán line. One support platform consists of 100 modular units, measuring 25 meters, 10 meters, designed as a globally standardized structure. Each airport operates a 4-platform cross-operation system. Ultra-large BLDC motors and composite wings generate enormous lift using only ground-supplied power, allowing ascent up to 10 kilometers under self-power. From 10 kilometers to 13 kilometers, rocket propulsion is scheduled to activate, and beyond 13 kilometers, wings and rockets operate in parallel, enabling continuous ascent up to 100 kilometers. At that altitude, the space-use vehicle separates and launches. The most critical component here is the 1.5 gigawatts class ultra-high power cable. Because the support platform operates solely on ground-supplied power, fuel mass is minimized and ascent efficiency is maximized. 3. Cables and winding systems, precision technology for the entire system. The ultra-high power cable is not merely a power line. It is an integrated composite line that simultaneously transmits power, data, and control signals. The cable is managed by a precision automatic tension control reel and winding system. This system analyzes cable tension changes, altitude-dependent temperature variations, wind pressure, and airflow conditions in real time, automatically adjusting winding and release speeds. Thanks to this technology, the support platform maintains stable posture during ascent despite environmental changes and pressure differences. This is a core technology that determines the overall safety and reliability of the system. Earth-use vehicles will be able to connect the entire globe within 2 to 5 hours. The support platform separates Earth-use vehicles at altitudes between 13 kilometers and 25 kilometers, where air density is extremely low. At these altitudes, vehicles can travel with dramatically less energy compared to conventional aircraft. This approach enables travel anywhere on Earth within 2 to 5 hours and delivers over 80% cost reduction compared to existing systems. Long-distance travel is no longer a problem of time, but of altitude. The support platform continues ascending to the 100 kilometers Kármán line, the boundary between atmosphere and space. The initial ascent phase where conventional rockets burn enormous amounts of fuel is handled by the support platform instead. At this point, the space-use vehicle separates and efficiently enters its desired trajectory toward the Moon, Mars, or space stations. This method drastically reduces the cost of space access and significantly lowers the entry barrier to the space industry. 4. Integrated engines, altitude adaptive propulsion. The vehicles are equipped with an integrated engine system optimized for altitudes around 25 kilometers, where air density is approximately 3 to 5%. Air-breathing propulsion at low altitudes. Hybrid propulsion at mid-altitudes, rocket mode in space. An onboard computer and hundreds of sensors analyze altitude, pressure, temperature, wind direction, velocity, and air density, switching propulsion modes in real time. This is not a single engine, but an intelligent propulsion system that adapts to its environment. Fully automated navigation and control. All flights are managed with high precision using GPS, inertial navigation systems, environmental sensors, and attitude control systems. Onboard AI and ground control centers operate a dual-layer safety system that manages flight paths, attitude, velocity, and separation timing. As a result, every flight is repeatable with identical quality, and operational uncertainty is minimized. 5. The Moon, Helium-3, and a 10,000-year energy era. The lunar surface contains abundant helium-3, a nuclear fusion resource that is extremely rare on Earth. Helium-3 produces minimal radioactive byproducts and is considered a clean energy source capable of sustaining Earth for 10,000 years. Space-use vehicles can repeatedly perform lunar base module transport, mining equipment deployment, and sample return missions. With the support platform lifting vehicles to 100 kilometers, both economic viability and operational feasibility become realistic. 6. Mars, a practical starting point for long-term habitation. The Giseung Platform system is designed to enable repeated transport of all modules and equipment required for Mars-based construction between Earth and Mars. 2 meters times 2 meters modules used directly in Mars bases. Reusable round-trip transport by space-use vehicles. Initial energy savings via the support platform. Long-distance flight stability ensured through autonomous navigation. Mars-based construction is no longer a distant future concept, but an industrially feasible phase. 7. The 2 meters times 2 meters module, a common architectural language for Earth, Moon, and Mars. All vehicles and space structures are built using a single standardized 2 meters module. This single standard becomes the foundational structure for lunar mining bases, Martian habitats, and space stations alike. Space construction is no longer specialized architecture, but a standardized process of mass production, transport, assembly, and construction. 8. The beginning of a new civilization. Once this system is completed, Earth transportation enters an ultra-high-speed era, space access becomes a realistic industry, the Moon becomes an energy resource base, and Mars expands into a functional habitation zone. Earth, the Moon, and Mars are connected into a single network of mobility, energy, and industry, marking the beginning of a new civilizational infrastructure. This is not merely technological advancement, but a transformation that redesigns humanity's living sphere itself, turning the long-imagined one-day Earth living zone and the space age into reality.